Okay, seems to be working. Okay, so hello everybody. This is Luboš Pirkl from CFD Support. Welcome to the webinar on Turbomachinery CFD, which is a CFD simulation workflow for all standard rotating machinery. The test case for today will be a radial pump. Just in case of technical problems, feel free to contact us in the future and we will answer all questions or reminders. The webinar is going to take up to 1 hour on how many of your questions or reminders will come. In the first part of today's webinar, I will briefly show you how to simulate a radial pump in Turbomachinery CFD. The second part, there will be a Q&A session dedicated to your questions and my answers. Feel free to put your questions or comments to the chat window or send us an email to info@cfdsupport.com and I will answer questions later in this webinar. Okay, so in the beginning, I'm going to be a little bit more general, so feel free to put your questions and reminders, and then I can go deeper and I can describe things more in detail. Okay, I guess I share you my screen now. So I'm gonna share my screen, which allow you to show. Which allow you to see what I see. So I believe you can see my screen now. Okay, so let me start with a brief description of what Turbomachinery CFD is. So Turbomachinery CFD is a unique software based on OpenFOAM. It was designed for CFD simulations of all rotating machinery, such as pumps, fans, compressors, turbines, water turbines, all of the stuff, both radial and axial machines, both compressible and incompressible flows. Turbomachinery CFD is complete CFD workflow. That's important. It's complete workflow. It covers complete path from the pre-processing over the simulation run to the very detailed post-processing of the results. Here's the Turbomachinery CFD interface. What you can see. This is how it looks like. And perhaps before I come here, let me just let me give just a few points. Let me put just a quick value proposal of Turbomachinery CFD. So I'll go to the website where I can search for Turbomachinery CFD. Yeah, and the very first result is Turbomachinery CFD, which is the product of company Support. Yeah, and I would like to tell you a little bit about its unique value because it's very important. Those are the reasons why you should decide to use this program. So number one is Turbomachinery CFD has no licensing policy, which means our clients can keep Turbomachinery CFD forever, and they can use it for unlimited number of users, jobs, or cores, and that gives their investment in Turbomachinery CFD permanent value. Number two is Turbomachinery CFD is fully automated, which means all the workflow from the start to the final engineering results can be run by a single command or by a single click. And all the process is being done automatically. That's it's extremely effective for this reason. Number three is Turbomachinery CFD is open source. That makes it easily customizable, and it's easy to modify Turbomachinery CFD to your purposes, to your workflow, to your what you're familiar with, and really to your work. And the last one, number four, is the real tutorials are included, so the user has no doubts about the best practice settings. So there are real machines that are already preset, so you can basically take one of them, replace the geometry, and modify the settings and run your case. there are also many other benefits using Turbomachinery CFD. I'm not going to go for all of them. I'm going to continue with Turbomachinery CFD workflow. So yeah, but perhaps the most important information is all the information is available online. So you do not need to remember very much information from this webinar. All the information is available online on our website. So you can navigate to Turbomachinery CFD website. There you can see a workflow example website where you can see exactly what are the Turbomachinery CFD inputs, what are the outputs, how to put the data in, how to pull the data out. Turbomachinery CFD is available both for Linux and for Windows operation system. Turbomachinery CFD is transparent. The trial version is available for free for 1 month period of time. So anybody can try Turbomachinery CFD, and afterwards he or she can decide to buy or not. So in the download section on our website, you can download a demo version, and you can try out Turbomachinery CFD immediately this afternoon. You can really easily do your tests, and after that it makes an impression on you. Then you can decide for the next steps. Okay. So there's the demo version for Windows, or for the Linux. So you can use Turbomachinery CFD in Windows, in Microsoft Windows, or in Linux. Yeah, there you can find all the instructions. There is especially a PDF which is called Start Step by Step. So where you can read what to do step by step to run your first, to run the demo and run your test case, which is quite obvious. And yeah, so yeah, okay, let's start working with the case of today's webinar. Let's start working on the pump now. So I'm back in Turbomachinery CFD graphical interface, and here's the Radial pump case study. Maybe I can show you. I'll go for a little while. I'll go back to our website, and for example, in products in Russian, there are some examples. What we are going to do today is the Radial pump. So this particular Radial pump has its study on our website. You can click on our website on it. So it's Radial pump. Yeah, so this tutorial has its website where you can see the example of use, a little bit about the workflow and about the results. Yeah, so it's the Radial pump. I'll go back to the Turbomachinery CFD. So Turbomachinery CFD is fully served from graphical interface. It's from this interface. The graphical interface of Turbomachinery CFD is the ParaView. You can also work from the terminal, but most of people prefer to work from the graphical interface. But the decision is up to you anyway, and you can also script Turbomachinery CFD, and you can run on clusters and many other ways to run it. So it's not exactly needed to run it from the interface. In today's webinar, I will work from Windows operation system. Just the information. The Linux workflow is exactly the same. So I would do exactly the same in Linux if I would be in Linux. So again, it's the user's choice. Okay, let's take a look on this particular Radial pump. tutorial. So by the way, all the tutorials can be downloaded on our website. Again, you can click to download and download cases, and then you can select any of machines that are the aim of the pump designer, of the engineer, is hunting for the pressure head, or for the head of this pump, the flow rates and torques, and of course the efficiency, which consists from these three quantities. CFD simulation has the same data inputs, and this is really important. The data inputs are the configuration file. So there's a configuration file which is represented by the settings of the case, and a surface geometry, which is a surface, like 3D data of the CAD data of the machine. So these two, configuration file and surface geometry. The configuration file is simply plain text file, which all the case settings with all the case settings inside. So I can go to I can show you the configuration file of this radial pump. It's called radial pump.tcfd. So the configuration file has the extension .tcfd. I can open it with Notepad++. Okay, so it's this simple plain text file is all the settings, which is read it in Turbomachinery CFD, and you can see all the settings in your left-hand sidebar. Okay, so when starting new simulation, you can either write your own configuration from scratch, but of course the most effective way in CFD, and especially in OpenFOAM, is to modify an existing tutorial to your case values you want to simulate. So I'll go back to the settings later in this seminar. I will now say a little bit about the surface model. So the surface model, it's the surface 3D CAD data. It's the STL format, and it can be combined from multiple components. This is important. So any surface model can be combined from multiple components, like the inlet tube, for example, I don't know, the impeller, and the volute, and maybe some outlet tube, etc., etc. Any number of components is allowed. Each component has its will have during the run. Each component has its individual mesh. What's important? Each component should be waterproof. So each component have to be waterproof, and ideally vertex to vertex. What I mean is by vertex to vertex is, we can take a look. So this is the inlet, right? The inlet of the pump. This is the inlet tube wall, and you can see the detail. The vertices fit each other. So this is what is meant by vertex to vertex. So this is my surface format, which is waterproof and consists of individual surfaces which are closed. That's important. And by the way, Turbomachinery CFD then goes create a mesh for the inlet tube, create a mesh for the volute and for the impeller, and make them communicate via merge them and make them to communicate via the interfaces, via special interfaces. Okay, so that's the surface format. Yeah. So what you do is you load the configuration file into the ParaView, and on the complete setup is in the bar, which is settings on your left-hand side, and there you can do all the case settings what you want to simulate. There are everything like boundary conditions, which surface files are used, which boundaries, of course the physics like viscosities, reference pressure, density, and operation points. Like you can compute multiple speed lines and multiple points for each speed line, so you can create complete characteristic maps with Turbomachinery CFD. It's always it's a matter of setting it and doing the computation. You can of course select how many processors will be used, whether steady state or transient simulation will be done. You can set the limits for your key quantities, which makes it robust to converge numerical order. Of course, the average quantities are computed. You can specify over which period it's going to be averaged. Yeah, some other special settings. Yeah, you can specify the boundary conditions here, and the mesh settings, of course. How yeah, it works like the following way. So for the meshing process, we use, or the Turbomachinery CFD use snappy hex mesh. So for each for this workflow, it's used snappy hex mesh, but it's one of possible ways. Of course, you can load the external geometry, which will be another topic possibly. So snappy hex mesh creates the mesh. So specify the basic background cell, and which is refined in with respect to the boundaries. And yeah, so that's the mesh settings, which is down in the settings. Yeah, and some others. So yeah, so once you do the settings, you can start the simulation. So the very important next step is, after doing the settings, you run the CFD manager, which is special plugin for ParaView. It's a colored icon with colored arrows. You can use this filter, and that gives you a CFD manager, which is a special set of plugins, a filter, which menu where you can say, okay, I want to write my case down, which is the open form case, which is being written down, and you can say write the case, and then you can work either manually or automatically. So usually most of the users work automatically, so you can click just on the button which is called run all, and that creates that starts the complete process. So the mesh is created, the setup is done, the simulation is run, and yeah, so the simulation is done and finished, and in the end the results are written down. Yeah, what's one of the best features of Turbomachinery CFD is you can anytime during the simulation, anytime you can view the results. You can view the integral results of all the important quantities. You can see the statistics. So anytime during the simulation, you can click you can have it regularly updated, and these HTML results report give you all the important information. How is your case developing? How it's converging? What are the flow rates? What are the efficiencies? what are the torques, how they develop in time, how they develop versus the flow rate. You can see the total pressure drop, total pressure difference, which corresponds to the head in pumps. You can see the averages per the interfaces. You can see how, for example, the total pressure is spent when flowing, or when the fluid flow is flowing through your machine. You can see how it develops in time, how it is on each interface. The same for velocity magnitude. You can see also the important angles, the circumferential and meridional angle averages, how they develop in time, how they look like against the flow rate, etc., etc. For pumps, we have a special function object which evaluates a cavitation risk. So you can see what's your cavitation risk, and comprehensive. And the point is this each individual simulation run has its result report, and you can update it anytime during the simulation, and you can store it later on, and you can compare these reports. So report is quite important. Okay, so this were the basics. I will take a look. So I can go a little bit back. I stop sharing my screen, which brings me back to me. So hi, hello, I'm back here, and now I'm gonna go take a look whether I have some questions in our email. Yeah. So I have to say I can't see. Well, yeah, I can't see any email yet here, and what I also need to do is taking a look whether I have questions in this webinar appear in any second in my second screen, and it's the webinar. It's okay. I'll click on it. Okay, it shows me I'm not signed, so it's unexpected a little bit. So I'll go here, okay, and I'll take a look. Okay. Yeah. So no question yet. No questions yet. So okay. So what do I do is I'll go back to the case. I'll go back to my test case, and I will continue. So okay, what is quite important, again, I'll go to the website for a while, to our website for a while. So yeah, and of course I'm sorry, I need to, yeah, I'll switch. I show you my screen again, which is quite important. Yeah, so I'll go to our website, and I will go ahead. So Turbomachinery CFD is pretty comprehensive. It works automatically. So you just put in the surface model and the configuration file, and all the process is done automatically. So the mesh is created, the simulation is set up, it's run, and the results are evaluated. For very detailed Turbomachinery CFD results analysis, we have created a special set of plugins to ParaView, which we call them TurboBlade Post. I'm sorry, it's the manual, so I'll go back. So the TurboBlade Post is a special set of plugins to ParaView, where you can do for example, the blade-to-blade view. You can plot, for example, the quantities around the blade at certain heights from the hub to shroud. You can do the meridional averages and many important operations to visualize your CFD results. For example, watch how perfectly is your leading edge attacked by the relative velocity, for example, or you can do several special plots using these special filters, which are pretty useful. Okay, so I'll go back to the case. So this is the Turbomachinery CFD. So yeah, you can compute multiple speed lines. So you can run your rotating machine on multiple speeds. Each speed line may have any number of points, and that creates the complete characteristics, like, I don't know, the efficiency maps or the torques or the head against the flow rate. That's pretty important. You can have them anytime. You can also anytime you can skip when you think you have converged already. You can skip to the next point. You can abort the calculation. You can abort the calculation and write current results. You can update the report anytime. So in this sense, it's pretty comprehensive, and it gives a huge value to engineers when they do their simulations of rotating machinery. And what is pretty important when working with CFD and OpenFOAM, especially with OpenFOAM and Turbomachinery CFD, you never start from scratch, right? You usually take a case and you just modify the differences from the case you want to compute. You put your data and just simulate. So it's pretty easy. The learning curve in Turbomachinery CFD is pretty nice, because you learn easily, you learn quickly, because it's, and also our technical support is amazing. You can just we always come with advices and with support, and we support you in your issues, so you're never alone. I'll go take a look if we have some questions. I have to say I can't see any questions yet, so maybe it's, yeah, which brings me, okay, so we have no questions yet, so I'll go. Okay, so okay, hi, it's me again. Yeah, so we have no questions. So the answer is well. So send us your questions to info@cfdsupport.com. We will your questions and give you share our experiences and give you the best what we know, and we will do our best to support you in your rotating machinery cases. So for this time, I would like to thank you for your attention, and we will be looking forward to meeting you someday somewhere. And yeah, keep foaming.